Hi everyone, and welcome to part 6 of coding Dogen, implementing the relational model. We're still quite some far away from actually going back into the implementation of the relational model, but we keep hacking away trying to solve our issues with the build. So if you remember, in our last episode we were facing a lot of red builds, and mainly the reason why the builds were red was because we don't really have the relational model across all the different operating systems and so forth. So we pushed a couple of changes to ignore conditionally the relational model, and that seems to have kicked in, so we see a lot more green. However, we haven't quite solved all the problems. So if I look at our build history, you can see here that we're still bumping into the limits for GCC, so the GCC builds are still not finishing, and we now have an additional problem on the OS X builds. So we pushed the fix for that. It was just a silly brew update error. It seems like the version of CMake is already the one we want, so brew for whatever reason decides that's an error to try to brew upgrade to the current version. So we pushed the fix for that already, and we're just waiting on the next build to go in. But however, we're not quite out of the woods yet, as we've seen from 50-minute builds that we have. We really have to get rid of the tests that we're running on continuous integration, and we have to run those only for nightlies. So we've finished most of the analysis for this work. So I'm just going to clean things up a little bit here in our agile view. So we have finished all the analysis for this, and we know what more or less we're going to do. We started some of this work during the commute today, and what we've done is we've in our main API model, as we call it, we've added an option for our variability overrides. If you remember, the way we're going to implement this is by allowing the definition of a profile purely for testing that enables all the options, and we could call that profile perhaps test profile, I guess, and it will be the opposite. Is disable all facets, so we enable all facets. And then what we can do is we're going to tell Dogen to override the setting of the profile. So for instance, here we're setting the profile to dogen.profiles.base.default profile, which is this chap here, base default profile. So we can have another profile here that overrides that. Our solution for that is this variability overrides. So started hacking the variability overrides. Now we have to restart Emacs. In fact, I'm going to, funnily enough, restart Emacs yet again. Got to the problem as to why my Emacs has been behaving strangely, and it's something to do with smart parentheses. So what I'll do is, I'm going to see if I can, before we start work, I mean this is already going to be a short session, but we need to disable globally smart parents. Let's see if it's possible to do that without restarting Emacs. Mode. Okay, so there is a smart presence global mode. I wonder if I can just do smart parents global modes disabled. Okay. Now I wonder if this solves our very strange behavior in C++ and CMake, I believe. Okay, so if I open up any C++ file, clearly we haven't got any yet. Let's say if I go to, say, the reference validator. Much better. So now we don't have that crazy behavior. So that's good. We got to the bottom of that. And also, I guess while we're here, we should set up our fly make. So another thing that's vital. C++ development, really. Okay, cool. That's good, because it's always easier not to have to restart Emacs. So we just start off with this mode here. So useful thing to have as well is if we go to slot 5 is to create a compilation. That's just so you can see what I see in my other monitor, which is a compilation window. And perhaps on 6, yes, on 6 we could have a Dogen shell. Okay, 5, 6. Okay, so I'm just gonna rename this shell slightly more sensible name. And away we go. Okay, so what I'll show you now is if I go up to build output, build output, yes. Client 9. Should probably delete the other versions. If I just locate a binary, I could type. So we just start off Dogen CLI. So you can see here if I have built latest. The general option. Interestingly, you probably need to do something like. Yeah, okay, that's interesting. So expect to see an additional set of options here related to modeling. So we have general output, logging, tracing, reporting, diffing, database. Okay, so what we really want here is to look at the commands line parser and have a look at the options. So this is the interface. Is this program options parser, which uses the boost program options library. Now in here, hopefully we should see. Oh, here we are, processing options. Very interestingly, we are not adding the process. This is actually a bug. We just detected processing options not being added. Interesting, I still. Okay, better now. Still experiencing some smart parents behavior. As I was saying, we seem to have had a bug here where we didn't add the processing options. Processing options are things such as the compatibility mode, the dry run mode, and the new option that I just added, which is the ViabilityOverrides. Not very clear as to why these options were not there. Seems like it needs travel far back enough for my undo. Let's just see some of the effects of smart prints over there at the bottom. So we should be okay now. So I'll just hop over to the compilation window and let's try to build with this. Looks good, so let's go back to the shell. Right now then. We just look at the main help commands. Hopefully processing is now available. And so you can see here we now have Variability Override and the database options that we added a while ago. In fact, to be honest, that's probably why we broke this when we are messing around with the database options. Probably removed the line where it shouldn't. Just out of curiosity, let's try and keep playing. It's a small file, so hopefully it will just work. So if I have a look at well, the problem of course is you can't see when something was removed. Okay, let's just remove the git blame and instead use the git time machine. No, git time machine. Normally git time machine normally allows us to go up and down. There we go. So I can just do previous and next in git time machine. So if I just say previous, see all the database options, and if we have a quick look at processing here, yeah, as you can see here, processing options are exactly where you expect them. And if I keep going forward in time, they still look okay, and then we add the database options, and we just seem to have done a bit of a mistake here. Probably should really have a test to make sure that these options are coming through, but we don't have at present. So let's just exit the git time machine, and the current state of the world is where we are right now. Okay, so let's just make sure we are really where we expect to be, which is program options parser, if I could speak. And now we've got the options coming through as you'd expect. Right, so the idea with this variability override is that we're going to have these tuples with, well, it's not a particularly brilliant format, but that's what we're going to use for start off with, a CSV format that gives us the coordinates of the model element that we like to change with the override. And then we're going to, during the configuration processing, we're going to use these overrides to override the metadata coming in. So we already have the variability overrides. Of course, must remember to yet again disable smart parents. Clearly the globally is not actually working for some reason. When we read these tuples, we need to take them into our options here, the viability overrides. And so just have a quick look here. I believe we are probably already doing that. Variability. So we are reading the variability overrides if they are present, and we're supplying them over to the processing option. So this is already being passed into the model processing configuration. It's part of our configuration. So the next stage then is to take the model processing configuration and to slot it into some kind of context. So you need to basically take it to the transforms. So because we are in injection, the context we need to affect is this context here. So what I'll do is I'm just gonna add something quickly here. Put the variability overrides in here as well. And just basically say, I mean, I could be really lazy. Probably this is not a good thing, but I could be really lazy and just copy the comments we have here. More elaborate than we need, I guess. I'm just going to take the base and just put the variability overrides here. I mean, as you can imagine, all we're doing here is propagating this across into the injection model. And the idea being that once we get to the injection model, we're going to have some data model representation of these as some kind of a graph. Which will use which will take the structure that we got. So if I just go back to Agile, so the structure we defined here: model name, element name, attribute name, and then finally get to the KVPs. And so what we really want is something that represents this structure here in this graph: model name, element name, and attribute name, so that we can quickly do a search by these attributes. And then for each of these we want to associate some kind of list of strings, of pairs of strings, which is sort of the raw format of the metadata, which we call taggables. So and that is going to be a property, perhaps, of the models. So as we enter in the context, we will need a transform that takes the raw data in our variability overrides, and it processes each of these models and then generates the taggable data for the overrides, and then quite intelligently in fact, I wonder if it doesn't even make more sense to just have a notion of tagged values and override tagged values. And then that would then mean that the data is just exactly where we want it, and we just need to have a transform that populates the override tag values. It's just the same way as we got the transform that populates the tag and the tagged values. So that would be really nice, because then we could just say take it from here, take it from there as well, and but of course the only problem is we need to make sure that we are taking into account the fact that overrides are overrides, rather than just they're different. They're supposed to basically, if it's depending on the type of the field that we're overriding, they're supposed to merge them with the collection in the case of collections, and for every other case it's supposed to basically override the name, to override the value of it. So we just ignore anything with that same key. So whilst we're processing these taggables, we need to do a quick lookup. And that's fine, because we know how to aggregate taggables inside of our factory, so we could do exactly the same thing as doing at present, and then just do a very quick lookup, and if the value already exists. So yeah, it's actually quite a neat solution, really, because it doesn't really require us to then go and create a structure of elements, model, and attribute for the overrides. So we just have the tagged values, and we have the override tag values, and then we just have to parse the variability overrides and populate these. That can be done as part of a transform here in our model production chain. Presumably the injection model already has the taggables populated from their source input. So for example, if it's dia, this chap here will be responsible for reading, as you can see we have a representation, a row representation here. They were already contained in a comment, I believe, tagged values exactly. So just copy these across in the raw dia representation. So we will need a transform that executes before the configuration transform. That leaves the object in right state. And then the configuration transform, which we can see, if I could spell, transform configuration. Interestingly, of course, again, still spelling error here. Slight problem with coding after a long day at work. Right, this is a configuration transform. you can see what the configuration transform is doing is it's taking these tag values and is slotting it into a configuration factory. Now, nothing stops us from supplying, just as we supply tag values, we can just as easily supply the override tag values. And then what we'll do is we just go to the configuration factory, not the mock one, the actual one. Chap here. So the configuration factory is going to then require some kind of aggregation. So as you can see here, we've aggregated the entries here. And we can do a very simple lookup to these aggregated entries. I mean, of course, these aggregated entries here are probably not a map. Well, they are a map actually. Map of string to lists. So this is exactly what we need, right? We need some kind of map so we can then look up for the override, and we can say, well, if this value exists on the override, depending on its type, in this case it's KVP, depending on its type, well, if it's a KVP merge, else just forget about the original. And just take value from somewhere else. Now we must take the value of the KVP, presumably somewhere around here. KVP K. And then, yes, you see we obtain a feature for that key, that's fine. Then we validate the binding, make sure we got the metadata at the right place. And then we must transform in other words, we must create a value. But there we are. So here we then create the value in the factory, so we can easily just use the overridden value after a lookup. So this seems like a very sensible implementation, and it's very straightforward implementation as well. So we've already added the variability override, so let's just start with the first task of seems to be manually adding data to our diagram. So let's do a very simple thing of trying to get from the options to the context. First we just need to code generate. So we'll just generate Dogen.injection.dia, and so we'll just have a quick look at what we got with this. No surprises here, hopefully. Context just got a little bit expanded. For good measure, we'll just convert and indent JSON model. As you know, this is required to keep our JSON models in sync. And then while we wait, we will just get the build going. Now, I don't particularly like Windows changing my workspaces, so I'm going to put this back into Git, which is what we want in this workspace. And in here we just have to fix up manually the JSON model. And this shouldn't really throw any surprises, so let's just do a couple of commits here. CLI adds power processing options, option description to one options. This was removed by mistake when we added the database option description. Okay, that's about this. So do then now we just have our context changes, and we can say here injection variability overrides context. And that would do. Okay, cool. So now we got this in context. The next thing we need to do is to just populate in our context factory something like this. We need to basically have access to both the options that are coming from the command line, which hopefully this guy has. So presumably there's this CFG. Yes, as you can see here we have model processing options. I'm not sure why they're called model processing rather than just processing. And we also have the variability override, so that's what we're looking for. And we also have things such as variability, and of course remember, you must always remember to disable smart params until I restart Emacs. Right, so if we just look for presumably the injection context, we're just filling them in as we go along, really. So, wonder what's the first reference to the injection context? This chap here. I'm tempted to do this at the very top, really, because there's not a lot of dependencies for this. At the same time, seem to be finding a nice little logic here. So, given that this is related to processing options, we can just say populate the variability overrides, and here we can just follow exactly the same pattern. And the pattern basically states variability overrides. This is just so we can lid on the code a little cleaner. Easy to read, cleaner. I don't know if it's cleaner, but right. So as you can see here, in this is not quite right. So in the injection context, we have the variability overrides. Now all we've done here is not very special, really. Just propagate it across. This is done. Tests. Nothing special should happen here. Hopefully, good, excellent. Again, we just commit this. Can say engine populate variability override context from options. Okay, so now very straightforwardly we moved the options to the next stage of the pipeline, and now the second thing we're going to do is we're going to go to our taggables and add the notion of override tagged values. It's identical to the regular tagged values. Here we can say something like data sourced from sourced externally, perhaps, that can be used to override model metadata from metadata in model. Okay, so the metadata sourced externally that can be used to override metadata in model. These are the override tagged values. Okay, so as you probably are familiar already, this is an object template. So once I update the object template, anything that uses that object template will be affected by it. In this case, these meta elements, which are the elements, the attribute in the model, will all be affected by this change because all of them are taggable. So we just go to generation again, and for the measure we will also update JSON. Save us a trouble. if you go to Git, we will see, as expected, that everything got affected by these changes. You can see here, element attributes, everyone inherits from him. And now we can add this chat building again. And while this is going on, we can have a quick look at what Git is telling us. And also take the opportunity to update our clocking. And we are running out of time. I think this is going to be a very short video today. Really don't want to finish much later than midnight. Good. Tests. And hopefully this will give us a clean build of health. Which is what we got. We can just say that we would like to injection add override values to tag object template. And so that's quite nice. We now have this notion of overrides. Now, of course, there's some bit is missing here, which is we now need to, starting from where our model starts, with something in context with ViabilityOverrides, we need to populate the overrides tag values. That is done via a transform, so we need a transform here somewhere. And that transform will be part of a model production chain. So we could say something such as perhaps overrides variability, oh no, tags tagged values overrides. And actually, to be honest, if you think about it, this should really be called tagged values overrides, not override tagged values. So, sorry, I'm a little bit fussy when it comes to naming. Let's just say we don't really want to take that commit just yet. Let's just stop for a second and fix the terminology here. So, tagged values overrides. Tagged value overrides. That seems a little bit more sensible. And then what we need to do is to just for a good measure, we seem to be doing this quite a lot, so it's easy enough to just run these 3 targets. Where are we? So again, we just need to quickly run all tests. First compile everything again, because it's kind of mount. What I'll do is, I think we're clocked off already. A little bit optimistic there. Let's clock the remaining time. And clearly nothing should break. Okay, that looks good. Let's just jump over to Git again. And let's just say, as we said a second ago, so add tag values overrides to taggable object template. Okay, that's good. So now let's go back to what we're trying to actually achieve here, which was we were trying to create a transform here. And this transform's job is going to be to take the tag value overrides, this chap here, and that could be very simply called transform or tagged value overrides transform, just to keep it, just to remain in keeping with our pattern here. And then its job is going to be to take in a context, of course, and then a model. So you see we already got the 2 bits of information we need. So we need some kind of apply methods, and we need that method to have a context. And we need model. Both of these are imparams. Now, of course, it would be really nice if Dogen actually, on the first generation, created all these methods as some sort of skeleton. And this is on our backlog, but sadly we haven't quite got around to doing it. It's actually quite an easy change, but there's so many easy changes on backlog. It's really littered with it, and we just don't have enough time, really. So right, there we are. We have AttackValue overrides transform, and that transform will take a context containing our availability overrides, and we'll update the model with AttackValue overrides. So yet again we'll generate no, we're going to convert, generate, no, we're going to convert, we're going to indent. This is really quite a boring thing to have to do all the time, but sadly not a lot we can do. One interesting thing is, of course, if you fail to save a diagram, nothing will happen, so we'll have to start all over again. That's a good measure. Let's just double check that. Now generating, which we are, convert. I mean, we could of course stop and fix JSON, but then, as you can imagine, we would be even more sidetracked. So this is one of the biggest problems we have in this world of ours. We can just create a very simple commit, injection, generate, tag, values, overrides, transform. It's just a skeleton, so it doesn't really do anything. So it just generates one for us. Then if we just open it, tagged, values, overrides, transform. This chap here. Right, now we just need to figure out what we're going to do with this transform. One good way of populating transform, if you're lazy like me, is to look for another one. So this will give us the basis of the transform. I mean, really, this is all code that we see Dogen should generate, but so much of that kind of thing. We just have to keep going. Uses the variability overrides to generate the tagged values overrides for each modeling element. Not for the affected, for the overread, and not for the appropriate modeling elements. Okay, so very, very simple. And here we'll have an equally trivial starting point. We mustn't forget to disable our beloved smart parens. And right, there we are. So we will need a couple of things when we create a new transform. Again, it would be really nice if we had these things co-generated automatically for you. We need to have all the infrastructure that's needed for this. It's very sad that we just haven't got the time to do it, because this is all literally copy and paste for all the transforms. But there you are. So we need some sort of tracing and some basic logging to tell us where we are. Right, so we to know a bit more about the context, we probably need something like a scoped tracer, which we already have. With this, we should have the basics of a transform. We don't really need to know many models and so on. Right, now then. So if you think about it, we have two sort of basic bits of work in this algorithm. The first thing is we need to take the tuples in CSV format, and then we need to locate the appropriate modeling elements. And interestingly, to add an additional twist to this, we probably don't want to parse this with every single model, if you think about it, because we have got overrides that could be for any of the models that we've loaded, and there could be quite a lot of these. So context starts off with the model overrides, sort of the global model overrides if you want to, and then, I mean, in truth this is such a simple, trivial case that I feel a bit tempted to simplify this. I mean, to be perfectly honest, the right thing to do really would be to take these CSV tuples and to first obtain the model, and once obtained the model we can then decide, okay, right, only parse the model, the entries that are relevant to you, to the model, the current model of the processing. They will complicate things further really. The simplest thing to do is to say, well, we'll just do work more than once, and we will match on model, and if it's not the right model, well, don't bother. Go through the lists, match on model, and then match on elements, and then match on attribute, and ignore anything that doesn't match. And of course you will do more work than you need to, but I mean, performance is not a problem, so who cares, right? So this is a really simple way of doing things. So let's say we do something like boost CSV parser, and Stack Overflow should help us hopefully. Boost spirit, boost tokenizer, right? Here we are. Boost tokenizer seems the simplest possible thing we can do. Create the vector has got strings, and actually, interestingly enough, if we look in our code base, in utility perhaps, string, splitter, pretty sure we already have something like this. Split scope, split delimited, split CSV, we do indeed. Now, interestingly enough, we do CSV of a list. So the idea with this is you can supply it with a string, and it will return us a list with the fields in that string. And I mean, a vector in this particular case would actually be nicer rather than a string, a list, sorry, because a vector would allow us to then say 0th positioned and so forth. Having said that, you can make do with this. We do also some trimming work here as well. Start with the string, with a list, I think. Oh, let's have a quick look at the time. Oh yeah, we're actually running quite close to the wire now. Okay, let's just see if this compiles so we can park things here. And let's just do a reference here to the splitter. And so we can just basically say now comments. Something like this is probably all static, it is indeed. So if I just, I will very much restart Emacs as soon as we finish with this video. See if I can once and for all get rid of smart parens. CCP, and away you go. So if we just do that, then that will remind us tomorrow where we are. And so just to recap, what we're going to try to do here is we just need to go to the context to obtain our variability overrides, split the string, and then check to see if the model name matches the current model. If it does, then we're interested in an entry. Then we look through the elements in the model, and for any element that matches the element name, we will then, well, we either update the list directly for that element, KVP, or if it's the case that the attribute is populated as well, we then look for the attribute, and if the attribute is populated, then we match on the attribute name, and we populate the tagged override tag values for those. And once we've done that, we've kind of more or less populated all of the entries here in tagged value overrides, and then we just need to handle the override case, which is very straightforward. That should be that. Seems very simple. So hopefully we will continue this tomorrow with the overrides. Now, before we go, let me just make sure that code we've got at present compiles. Of course it doesn't. This as well, making sure it compiles and then pushing it. So the problem we have here is that we are attempting to perform some I/O in the model. We forgot to include model I/O. And there we are. And then for good measure, let's make sure all the tests are passing. And they are. We jump over to Git. We, of course, sure we clock the time as we should. It starts at 46. So we will just basically add a skeleton for tags. Transform. Okie doke, so let's just make sure we can push that. And everything should be hunky-dory, hopefully. One quick check that our builds, yeah, as you can see here, now this looks a lot off here, and that's as expected, not really going our way. And hopefully should also see happier Windows builds. Still failing apparently. Let's have a quick look. Ah, see, we're already getting some greenery here. Let's just cancel this build. And that's the latest and greatest run. And hopefully tomorrow we should start to see really some greenery in the Windows builds. Our test model is failing. Because we are attempting to build ODB in the test model. Probably should disable that on Windows at the moment as well, whilst we are trying to address these issues. So, okay, this thing is all for today. Made a little bit of progress, not quite as far as we should really, but I'll see you in the next video.